graphing more functions, but we're going to look at this rational functions. Everything we studied so far with the graphs, with concavity, increasing, decreasing, max, min, if there is anything. So let's choose. There is a little bit more information here. I didn't mean that, I meant this. There is a little bit more information here because of the asymptotes. So this is what we are going to, this is when we are going to add in the asymptotes. I meant to go click on that actually. So we're going to put them in slowly but surely. And that will be the end of graphing. Okay, page 305. Good. So the first, we start slowly and we build towards graphing. So the first thing is something called vertical asymptote. So we'll clarify this again. I know you know it from college algebra, but we start from scratch. So first, let's choose a problem from here. Any problem you would like to work on.
Number 2?
Number 2. So with number 2 on page 305, we have f of x equals 2x minus 3 divided by x minus 5. Perfect. So first of all, you remember, I'm going back to the previous notes. I did not shred them yet. We're asked to graph. So that's how we started, by finding the domain. That's what we have to do. Now, for this problem, we are not asked to graph, but normally that's what we're building. We're building slowly but surely, step by step to get to graphing. So the first step, it has to be always the domain. Can anyone tell us what could the problem be here? What could the issue be? In a rational function. With any rational function, what could the problem be?
As denominator is never equal to 0?
Brilliant. The denominator can never equal 0, which means this function will never exist for which value of x?
5.
Exactly. So this function is not defined at 5. And there is a little trick here that I would like you to remember. Can I simplify? Is there a factor? I'm going to erase it. I'm going to write it in pencil. Is there a factor here of x minus 5? You probably cannot even see it. Is there a factor of x minus 5 that I could simplify x minus 5 with? It's silly. Of course, you have to say no. There is no factor that you can simplify. I don't have an x minus 5 at the top to simplify. So therefore, x equals 5 is a vertical asymptote. Vertical asymptote. And what does that mean? We're not graphing the function, but I just want to discuss what happened at 5. So this is the coordinate system. We have to graph the asymptotes always. But the asymptotes are not part of the graph. So I have to graph the asymptote as a dashed line. And I have to write x equals 5. The function cannot cross the vertical asymptote. Now, what happens here? Okay, the function is undefined at 5. I know there is a vertical asymptote. So what? So what? What does this mean? Well, it means this, that the function either goes to infinity on this side and to negative infinity on this side, or goes to negative infinity on this side and positive infinity on this side, or infinity to this side, infinity to this side, and negative infinity to this side, and negative infinity to this side. What determines that? Yes, you may like it or not, we have to go back to the limit. This is why we studied this in chapter 1. So let's dig deep in our concept of limit, and please tell me what happens here and here. What are those limits?
From the left, it goes to negative infinity, and from the right, it goes to positive infinity.
So you put in 4.9, and 4.9 gives a positive here, but gives a negative here. A positive of a negative is negative infinity. Brilliant. You plugged in 5.1, this gives a positive. Positive from the top with positive from the top gives a positive infinity, which means that on this side, the function will approach the asymptote going towards negative infinity, and from the other side, it will approach the asymptote going to positive infinity. That's the concept of a vertical asymptote. And now I want to talk a little bit about what I was talking here. Okay, so what if the function is like this? This is our function. I will ask the same question. You cannot look at the top. I will ask the same question. What value of x makes this function undefined?
5.
Yes. But look what happens in this specific case, which is not that case. I don't want you to get confused. I made up another problem to discuss something. Here, I still have to write this, but I'm allowed to simplify now. After I stated the domain, I'm allowed to simplify, and then I will be graphing this function. However, at 5, I cannot plug in 5 here. But I will have to determine the limit as x approaches 5 from the left, and the limit as x approaches 5 from the right. What do we get?
Negative and positive.
You have to plug in 5. When we determine a limit, we have to plug in, as we did over there. Here we could not plug in 5, we had to plug in 4.9. Here we could not plug in 5, we had to plug in 5.1. But this is a polynomial. Always ask, what do I do? How do I find the limit of a polynomial? So what will be the answer? Here and here.
They're
Is
both positive.
Say it again.
Positive.
But what is it? Here you could not give me a number. So you had to say, okay, I'm dividing a number by 0. As we remember, a number over 0 has 3 possibilities. Negative infinity, infinity, and d and e. But the limit of a polynomial has only one possibility.
It's 7.
Yes, because 5 times 2 is 10, 10 minus 3 is 7. 7 in both cases. And then 5 comma 7, what type of point will that be?
It would be an open point.
An open point. See, we are graphing this function, although we analyze this one, but I cannot disregard what I found at the beginning. This function is still undefined at 5. So it will become an open point.
Okay, I have a question.
Yes.
How did you cancel out? Where did you get another, like, x minus 5?
Okay, So as I said, I created a new problem to make a point.
Okay, this is a new problem.
So that's why I drew this line. That's why I said, do not get confused. I created a new problem because, see, if I say to you, the function is undefined at 5, it will always be a vertical asymptote, that would be incorrect. That statement is incorrect. Only if there is no factor that I can simplify with, then the statement is correct. So that's why I showed you a situation in which you cannot conclude that because x cannot be 5, automatically that's a vertical asymptote. Only if you cannot simplify a factor of x minus 5 with a factor of x minus 5, which we did not have here.
Okay, yeah, makes sense.
Better? Okay, perfect. Now let's go back to the book. This is, what page am I on? I'm on 5. Let's go back to the book. I'm going to share. Good. So let's analyze another problem and then move on.
You're number 6?
Number 6. Okay, with number 6, we have f of x equals x plus 2 over x cubed minus 6x squared plus 8x. Perfect pick. Thank you very much. Good. So again, we cannot look at the numerator. We never state the conditions for the numerator unless it's a radical or a natural log or whatever. So this function is undefined when, or for the x values that make what?
Zero.
For what?
For the factors of the bottom.
So the denominator. Very good. X cubed minus 6x squared plus 8x. Awesome. Very good. So now how do we address this? What is the degree of this polynomial?
3.
Very good. How many solutions do we expect?
3.
Very good. Awesome. The degree is 3. Solutions 3. Yes, we can factor. Let me show you again another option. And we will factor. But always remember you have this option here in apps, number 9. Polynomial root finder. It's a degree 3. Okay. Yes. Yes. Okay. First coefficient is 1. The next coefficient is -6. Be very careful, it's coefficient of x squared. The next one is +8. And the last one is 0 in our case. And we will have to get to 3 solutions. And there are 2, 4, and 0. This is an easy situation because I will factor out x. I have to do that. Then I get x squared minus 6x plus 8. And I'm sure that you can factor this very easily and give us the solutions.
-2 and -4.
Yes. So then the 3 solutions are
0, 2, and 4.
very good. So careful. When we factor this, I have x minus 2, x minus 4. I have to be very careful. Is there a factor of x plus 2 here that I could simplify? No. So x cannot be simplified, x minus 2 cannot be simplified, x minus 4 cannot be simplified with a factor from the top of any of these. Don't correct anything. But if I have this situation, I'm going to delete it. If I have this situation, which will become vertical asymptotes and which will not be vertical asymptote? All these in our case are VAs, all of them. X equals 0 is a vertical asymptote, x equals 2 is a vertical asymptote, x equals 4 is a vertical asymptote. But what if I have this situation? Don't correct anything because I'm going to erase this.
4 would not be an asymptote.
4 will not be an asymptote because I will simplify it. It will be an open point because I will be simplifying it. That's the point I'm making. Just remember Vertical asymptotes are at the points where the function is undefined, the rational function is undefined, but whenever we can simplify a factor that is no longer a vertical asymptote. Awesome. Perfect. Okay, moving on. I'd like us to talk about, where's my book? I'd like us to talk about horizontal asymptotes now. So let's choose a problem.
$26.
26. Good. So in 26 we have f of x equals 6x to the 4th plus 4x squared minus 7 divided by 2x to the 5th minus x plus 3. It's a perfect pick, but allow me to pick one more before this one. I'm going to pick 17 first, and then we'll work to 26. So f of x equals 6x over 8x plus 3. Okay. And we'll come back to that. You'll see in a moment why I needed an easier one first to discuss the horizontal asymptote. So remember what we had a minute ago. So we established that x equals 5 is a vertical asymptote, and we needed the limits left and right to see where the function is going. So without these limits, we don't know where it's going, left and right. Okay. So when we talk about horizontal asymptotes, we talk about a horizontal line this time. For example, something like this. Let's say, for me, this is y equals 2. So the horizontal asymptote is y equals 2. Remember that I said for the vertical, the function can never cross. It's not possible. It's undefined. It will never cross the vertical asymptote. However, a function can cross a horizontal asymptote. I'm going to give you an example. So it can do this. This is possible. Okay, so please remember, horizontal asymptotes a function can cross. Vertical, never, ever. Okay, so I'm going to move away from this graph again. So let's say I have a horizontal asymptote, which is y equals 2. So the limits at infinity of this function, limit as x approaches infinity of 6x over 8x plus 3, and limit as x approaches negative infinity from 6x over 8x plus 3, should be 2 if the function has a horizontal asymptote at 2. Okay? So it means that the function either approaches from below, not both, or from above, or this in the negative infinity towards negative infinity is this or this, not both. It will not be a function, right? So I need to determine the limits. So this is in my example is 2, but what will be in our example? What will be the limit here? And remember what we do, we factor out the degree and simplify. But we also know what this answer is. If we don't remember what the answer is from the previous class, then let's do it. We have to factor out x here. Nothing needs to be done at the top, but we have to factor out x here and then simplify. Anyone would like to give us the answer, or we'll show step by step? And I'll come back here. Okay, let's do it step by step. So we have limit as x approaches infinity, 6x, it's already done. Here we factor out the degree. Can anyone tell us what should I factor out? Anyone?
X.
Yes, the degree, very good. And what is left in parentheses?
8 plus 3.
But if I write a plus 3, that's not 8x plus 3.
3 over x.
3 over x indeed. So x times 8 is 8x. X times 3 over x is 3. Is that okay? Good. Now we simplify this and we get 1. Where does the numerator go? So remember, we did this because this is infinity over infinity, right? And we don't know what that means. So the numerator goes to
the denominator.
The numerator goes to 6, and the denominator goes to
8.
very good, because we know already that this approaches 0. Awesome. So simplified by 2, and we get 3/4. And that's how we get the 3/4 here. So that is the horizontal asymptote. Not 2 in my simple example here, but 3/4. And the function will approach from below or from above. We'll figure it out when we have to graph. Now, we are ready for 26. So let's find the limits. So for 26, I'm going to copy it again. So 6x to the 4th plus 4x squared minus 7 divided by 2x to the 5th minus x plus 3. We don't know what this is before,